Something is wrong with the sun. You can't see it. You can't feel it. And no instrument on Earth will ever detect it happening in real time. But buried deep inside that blazing sphere of light, a countdown has already begun. A countdown that started before the first fish swam in Earth's oceans, before the first mountain rose from the sea. The sun is not going to last forever. And what it does when it goes will be the most violent, most beautiful, and most terrifying series of events this solar system has ever witnessed. The question is not whether it happens. The question is, what happens to us? Over the next 10 minutes, you're going to witness the complete death of our sun. Every stage, every consequence. You'll watch it swell into a monster large enough to swallow 3 entire planets. You'll experience an explosion so powerful that for a few seconds a single dying star outshines every sun in the galaxy, and yet no one outside would see a thing. And at the end of the story, there is nothing left. No sun, no earth, no warmth, no light. Just a cold, dark object drifting silently through a solar system that no longer exists. This is the most important story in the history of our world, and almost no one ever thinks about it. To understand how the sun dies, you first need to feel how alive it is right now. Picture this. At the sun's core, the temperature is 15 million degrees Celsius. The pressure is so extreme that hydrogen atoms are stripped of their electrons and slammed together at nearly the speed of light. Every single second, the sun converts around 600 million tons of hydrogen into helium. That's not an abstraction. To put that in perspective, imagine the Great Pyramid of Giza. The sun burns through this equivalent of hundreds of Great Pyramids worth of hydrogen. Every single second. That energy takes around 100,000 years to travel from the core to the surface. The sunlight warming your face right now began its journey before modern humans existed. The sun has been doing this for 4.6 billion years, and in that time it's done something remarkable. It created us. Every atom of carbon in your body was forged in the belly of an earlier star. The warmth that allowed life to survive on Earth, that came from this one. But here's what most people never think about. Every second the sun burns, it uses fuel it can never get back. The hydrogen in that core is not being replenished. It is not infinite. It is being consumed. Right now, the sun sits in what astronomers call the main sequence, the long, stable middle age of a star's life, where the outward push of fusion perfectly balances the inward pull of gravity. It has roughly 5 billion years of hydrogen left. 5 billion years. That sounds like it solves the problem. It doesn't. Because when that hydrogen finally runs out, the sun doesn't just stop burning. It transforms. And nothing in the solar system will ever be the same again. 5 billion years from now, the last reserves of hydrogen in the sun's core begin to run out. And for the first time in the star's long life, the balance breaks. Think of it like this. For billions of years, the sun has been in a permanent tug-of-war with itself, gravity pulling every atom inward, fusion pushing outward with the force of a continuous nuclear explosion. These two forces have been locked in perfect balance for longer than Earth has existed. That balance is the sun. That balance is life. But as hydrogen runs out, fusion weakens. Gravity doesn't. The core collapses inward under its own weight. And here's the twist no one expects. As the core compresses, it gets hotter. Not colder, hotter. That rise in heat radiates outward into the sun's surrounding layers, and those layers respond. They begin to expand, slowly at first, almost gently. But there is no going back. The most catastrophic transformation in the history of our solar system has begun. And by the time it becomes visible from Earth, Earth will already be gone. 5 billion years from now, the last reserves of hydrogen in the sun's core begin to run out. Here is the part of this story that most documentaries skip. Earth doesn't wait for the red giant to die. Long before the sun swells into its final form, it gradually grows brighter. Not dramatically, not all at once, just a fraction of a percent brighter every 100 million years. But fractions add up. In roughly 1 billion years, 4 billion years before the sun becomes a red giant, that slow brightening will be enough to end almost everything on this planet. Here's how it happens. As the oceans warm, they begin to evaporate. Water vapor fills the atmosphere. And water vapor is one of the most powerful greenhouse gases in existence, meaning it traps more heat, which warms the oceans further, which releases more vapor, which traps more heat. A loop with no exit. Scientists call this a runaway greenhouse effect. You may have heard that phrase in a different context. On Earth, a runaway greenhouse effect is the thing we're trying to prevent. In 1 billion years, it becomes the thing we cannot stop. The oceans are gone. The average surface temperature sits at 70 degrees Celsius, hotter than any oven in your kitchen on a good day. The atmosphere is thick with steam and carbon dioxide. No forest survives, no animal, no complex life of any kind. Perhaps somewhere in the deep rock, microscopic organisms still cling on in the darkness. But the world as we know it, the one with cities and coastlines and seasons and skies, that world ends quietly, without a single explosion, without anyone watching. Simply warmth, slowly becoming something else. And the most terrifying part, the sun is barely even warming up yet. Five billion years from now, the last hydrogen in the sun's core is gone. Hydrogen burning shifts to a thin shell surrounding the collapsing core. A shell that burns with far greater ferocity than the core itself ever did. And the sun's outer layers receive more energy than they have ever had to handle. They expand, slowly at first, then faster. The sun grows to 10 times its current size, then 50, then 100. At its peak, the sun is estimated to expand to between 100 and 200 times its current diameter. To put that another way, if you placed today's sun at the center of a football stadium, the red giant would swallow the entire stadium, the car park, and every street for miles around. Mercury disappears first, instantly. Venus is next. And then there is Earth. This is where science gives us two possible futures, and neither of them is what you'd call survival. In the first scenario, as the sun expands, it sheds mass, enormous quantities of it, carried away on intensifying solar winds. With less mass, the sun's gravity weakens. Earth's orbit responds, drifting slightly outward, pushed away by the diminishing pull. Earth survives the expansion, technically. But survive into what? The surface temperature climbs past 1000 degrees Celsius. Every ocean that hasn't already evaporated burns away instantly. Every rock liquefies. The atmosphere, what's left of it, is torn apart by tidal forces and radiation. What's left isn't a planet. It's a scorched, airless, molten sphere of rock, orbiting the corpse of the star that once kept it alive. In the second scenario, the tidal forces from the expanding sun drag Earth's orbit inward instead, closer, slower, until Earth crosses the threshold, enters the outer envelope of the red giant itself. Atmospheric drag slows it down, Earth spirals deeper, and within a few decades of crossing that threshold, it's gone. Not destroyed in a single dramatic moment, just absorbed, consumed by the star that created it. Either way, no Earth remains. Not as a world, not as a memory, not as anything. But what comes next? What happens to the sun after it swallows the planets it once warmed? The answer is something that science can barely describe. As helium burning fades, the sun enters its final instability. The core contracts for the last time. The outer layers, already stretched thin from the red giant expansion, already barely held together, begin to detach. Not all at once, in layers. First thin wisps carried outward on the last solar wind, then thicker shells, then entire envelopes of material peeling away and expanding into space. Over tens of thousands of years, the sun sheds nearly half its remaining mass. And what's left at the center is the sun's core, exposed for the first time in 5 billion years. It's roughly the size of Earth, but it burns at over 100,000 degrees Celsius, 5 times hotter than the sun's surface today. And it does something remarkable. It floods the surrounding gas with ultraviolet radiation so intense that the gas begins to glow. Not reflect, not scatter, glow from within. This is what a planetary nebula looks like. One of the most visually spectacular structures in the known universe. A glowing shell of color, blues, greens, golds, reds, expanding outward at tens of kilometers per second. And it is nothing more than a dead star's last exhale. The name is a historical accident. Early astronomers peering through primitive telescopes thought these glowing disks resembled planets. They named them accordingly. What they were actually looking at was a star's obituary, written in light, across light years of space. This light show lasts approximately 10,000 years. Then the gas disperses into the interstellar medium, enriching the galaxy with carbon, oxygen, nitrogen, the raw material for future stars, future planets, perhaps future life. Somewhere in some distant future, the atoms that once made up the sun will be part of something new. But for this solar system, there is nothing left now, except one small object, sitting alone in the dark. What remains of the sun is called a white dwarf. It is approximately the size of Earth, but it contains the entire mass of the old sun, compressed into that tiny volume. The gravity at its surface is 350,000 times stronger than what you feel right now. If you could somehow stand on a white dwarf and pick up a teaspoon of its material, you'd be holding something that weighs around 5 tons. There is no fusion happening here, no burning, No nuclear reactions of any kind. The white dwarf is not a star anymore. It's a memory of one. A hot coal pulled from a furnace, still glowing, still radiating heat into the surrounding void, but with nothing left to add to it. Over billions of years it cools, then trillions, until, in a timescale so vast it makes the current age of the universe look like a single afternoon, it fades into something astronomers call a black dwarf. No light, no heat, no radiation. A cold, dark, inert sphere of compressed matter, drifting silently through a solar system that no longer has planets to orbit it. Here is perhaps the strangest fact in this entire story. No black dwarfs are believed to exist anywhere in the observable universe. Not one. The universe is 13.8 billion years old, and that is not long enough. No white dwarf has had sufficient time to cool into a black dwarf yet. They are theorized. They are inevitable. But the universe simply hasn't been around long enough to produce one. The first black dwarfs won't exist for quadrillions of years. In a universe so old, so cold, so dark that the stars we know today are a distant memory, our sun will leave behind one of the first, a cold stone in an empty sea, the last evidence that any of this ever happened. We started this story looking at the sun, and we ended the same way. Because right now, this morning, wherever you are though, the sun rose. It will rise tomorrow, and the day after. For billions of years, it will keep rising. That part of the story isn't changing yet. But every time it rises, it is spending something it will never get back. The hydrogen burning in its core right now began forming in the first minutes after the Big Bang. It survived 13 billion years of cosmic history to end up inside our star. And right now it's being consumed at a rate that makes human comprehension feel completely inadequate. Every ocean you've ever seen, every mountain, every person who has ever lived, every civilization that has risen and fallen before we could write its name down. All of it exists in the narrow window between the sun's birth and its death. We are not permanent. Neither is this planet. Neither is the star we orbit. We exist in a moment of warmth between two eternities of darkness. And the remarkable thing, the thing that should stop you in your tracks, is that the warmth is here right now. The sun will die, but not today, not tomorrow, not in any time frame that should diminish how extraordinary it is that it exists at all. Right now it is burning at full force. Right now it is the reason anything on this planet is alive. And for a star with 5 billion years of fuel still in its core, that is not a small thing. That is everything there is. If watching the sun's entire life, from this morning sunrise to its final dark breath, left you with something you can't quite name, that feeling has a word. Awe. Subscribe to Alternate Earth Media. Every week we go somewhere the universe becomes impossible to ignore. We'll see you in the dark.